Welcome to our class. We are studying periodic table chapter. Yesterday we started periodic properties. We have some important periodic properties. Mainly those are atomic size, ionization energy, electron affinity, electronegativity, non-metallic character, electropositivity, metallic character. Like that, we have some periodic properties. So we are going to discuss the definition of all those things, periodic properties, and also those periodic properties, what happens in group and period, that we are going to study now. So among the periodic properties, yesterday we completed the first periodic property, that is called atomic size. Atomic size we have discussed, we already discussed that. Okay. Then second periodic property, write down ionization energy. Ionization energy. Ionization energy. It is also called enthalpy. Ionization enthalpy and ionization energy both are same. So it is abbreviated as IE. Ionization energy means IE. So in order to understand this periodic property, ionization energy periodic property, first of all, you want to know the definition of ionization energy. First of all, you want to understand the definition of ionization. What is ionization energy? Okay. So ionization energy means just you write down. I will explain very clearly. You write down notes. Ionization energy means the energy which is needed the energy which is needed to remove or withdraw. Both are right. To remove or withdraw electrons, to remove electrons from outer orbit, So outer orbit, you know, this is valence cell also. Outer orbit is also called valence cell, you know this. So the energy which is needed to remove electrons from outer orbit of a gaseous atom. Is called ionization energy. Okay. So here, what is ionization energy means? Energy which is needed to remove electrons from valence cell of a gaseous atom. For example, see here, I write sodium. You know this sodium atomic number is 11. You know, so total configuration is 1s2, 2s2, 2p6, 3s1. Because atomic number is 11, you know. Atomic number is 11 means total electrons are 11. Just we write here 1s2, 2s2, 2p6, 3s1. So 2 plus 2 4 plus 6 10 plus 1 11. Here 3s1 is nothing but valence cell outer orbit. Third cell is nothing but outer orbit. You know, PS is valence cell outer orbit. So I can draw here sodium atomic structure. See, this is nucleus, first cell, then second cell, then third cell. Okay. So in first cell, how many electrons? 1s2. Here 1s2. Here 2s2 2p6. 3s1 means only one electron is there. No? 3s1 means only one electron. 3s1 means only one electron. Okay. So that means here sodium, you can observe sodium atomic structure. Here sodium can have one valence electron in the outer orbit. In valence shell, it has only one electron. Okay. So we are required, we are applying energy, we are required or we are needed to remove this electron. To remove this electron, the energy which is needed to remove this electron from the gaseous atom. Look here, we are applying the energy. Okay, we are applying the energy to remove the electron from outer orbit. You know, to remove the electron from outer orbit. That much of energy, how much energy we needed to remove electron from outer orbit, that energy we call as ionization. Understood? So, for example, here Na, you can withdraw the electron. That means you can remove the electron minus E. So, when sodium loses one electron, it becomes Na plus and releases energy. And it releases energy. This energy we consider as ionization energy. That means here ionization energy which is needed to remove the electron. Ionization energy, that means the amount of energy which is required to remove the electron from sodium atom. So that energy is called what? Ionization energy. Is it clear now? Energy needed to remove electron from the outer orbit, whatever the amount we needed here, required here, that amount of energy we consider as ionization energy. This is called first ionization energy. This is called first ionization. If you want to remove two electrons from the system, then that is called second ionization energy. For example, whenever you want to remove three electrons from the atom, then that is called third ionization energy. But here no need to discuss all those energies. Just you have to understand the definition of ionization energy. Okay, you write down this. Completed. So after completing the definition, we can study the change of ionization energy in group and period. So in group, ionization energy, right now, ionization energy decreases from top to bottom, in the group, from top to bottom in the group, because ionization energy decreases from top to bottom in the group because atomic size increases down the road, down the road. Write down this ionization energy decreases from top to bottom in the group. Why? Because atomic size increases down the group. Okay, you write down as size increases, the attractions of nucleus over the valence electrons decreases. As size increases, the attractions of nucleus over the valence electrons decreases. So we require So we require less amount of energy, less amount of energy. We require less amount of energy to remove electrons. To remove electrons. This is the reason why ionization energy gradually decreases down the road. You write down theory. I explain with example. So you try to observe first year group elements. Always you take first year group elements as examples because they are easy to understand with this first year group. So first year, what are first year group elements? You know, hydrogen atomic number is 1, lithium atomic number is 3, then sodium atomic number is 11. See here this configuration is 1s1. Here this configuration is 1s2, 2s1. Here this configuration is 1s2, 2s2, 2g6, 3s1. You know, nucleus only first cell electron is there in hydrogen. In case of lithium, nucleus around this how many cells? 2 cells. 2 cells are there. In second orbit, we have 1 electron. Like that, in sodium atomic, you try to observe sodium atomic structure. Here, 3 cells are there. Valence electron, 1 is present in third orbit. Here, what happens? You try to observe from top to bottom. You try to observe from top to bottom. What happens? Cells increases. Cells increases. So number of cells are increases. So that what happens? Size increases. Size increases. By that what happens? The attractions in between plus and minus decreases because distance increases, no? Because distance increases. Distance increases, no? So that attractions of plus and minus decreases. That's why you can easily to remove this electron when compared with lithium, when compared with hydrogen. That means less amount of energy is enough to remove this electron. That means, for example, here we need ionization energy. For example, 100 kilocalories per mole. Okay. Here we need only the 70 kilocalories per mole energy is enough to remove outer electron. In this case, for example, here only 30 kilocalories per mole energy is enough. Have you understood why ionization energy gradually decreases? Why ionization gradually decreases? Here less amount of energy is enough to remove the electron from the sodium when compared with above one. Why? Because here attractions are less. Attractions are less. Distance increases, attractions are less. That's why you can remove very easily. Very easily. You can withdraw electron very easily because attractions are less. Okay. This is the reason. See here, ionization energy decreases from top to bottom in the group because atomic size increases down the group. Size increases down the group. As size increases, what happens? Attractions of nucleus over the valence electrons decreases. Here attractions are decreases. So that we require less amount of energy to withdraw the electrons from larger size atoms. Is it clear? Okay. So in group, what happens? This is group, you know, this is group. In group, ionization energy decreases, IE decreases because size increases. In group, what happens? Ionization energy decreases. Clear? Is it clear? Okay, down the group, what happens? Ionization energy decreases. Here, the important thing you remember: ionization energy down the group from top to bottom decreases because size increases, so that attractions decreases. So we need less amount of energy to withdraw the electron from larger sized atoms. Okay. Then this is group. Here what happens? Ionization energy in group we study. But what about in period? Right up, but period. But ionization energy, IE, ionization energy increases in period from left to right, from left to right, because atomic size decreases. Understood? Because atomic size decreases. Because atomic size decreases. Okay? If size increases, ionization energy decreases. If size decreases, ionization energy increases. That means reverse with each other, you know. Okay? I give you relation. I give you relation. See, ionization energy. What the relation we have in between ionization energy and size means ionization energy and atomic size both are reverse with each other. Both are reverse with each other. Okay? You have to write this relation. Ionization energy reverse to atomic size. If atomic size increases, ionization energy decreases. If atomic size decreases, ionization both are inversely proportional with each other. Clear? Okay, I give you example. See, for example, boron is there, carbon is there, nitrogen is there. Here atomic number boron 5, carbon 6, nitrogen 7. These are belongs to second period, you know. Second period. Here what happens when we move from left to right? Left to right, what happens? Size decreases. Size what happens? Decreases. Atomic size decreases. So ionization energy what happens? Increases. Ionization energy increases. You have to write this one. Ionization energy decreases because as size decreases. Ionization energy IE. Ionization energy decreases because as size decreases. As size decreases. Okay, this is the matter about ionization energy. I think you understood very clearly. Okay, after completing ionization energy, then third periodic property, what is that? Electron affinity. Write down electron affinity. I want to remove this. Electron affinity. Electron affinity. AFFI affinity. AFFI NITY. This is abbreviated EA. Abbreviated as EA. Electron affinity. So to understand electron affinity, before that we want to know the definition of electron affinity. What is electron affinity? We will see now. Electron affinity means, you write down. I explain very clearly by taking examples also. So electron affinity means the energy removed, or released, the energy released, when electrons are added to the energy. You write here the amount of energy, released when electrons are added to the amount of energy released when electrons are added to the valence cell. to the valence cell of a neutral gaseous atom. Neutral gaseous atom. The amount of energy which is released when electrons, whatever it is, electrons are added to the valence cell, nothing but outer orbit of a neutral gaseous atom is called electron affinity. Okay. See, for example, chlorine is an atom. This is chlorine is a gaseous atom, particularly neutral one. Neutral means it cannot have any charge. Chlorine is a neutral gaseous atom. Okay. To this neutral gaseous atom, you can add electrons. For example, you can add one electron. Okay. Adding one electron to the neutral gaseous chlorine atom. By that what happens? This chlorine can take some electron, it becomes as an anion. It forms anion and releases some amount of energy. This amount of energy we consider as electron affinity. So here, amount of energy which is released when electron is added or are added to the valence cell of a neutral gaseous atom. Here, one thing you remember that the neutral gaseous atom to form anion. Just you can make this word. To form anion is called electron affinity. Of a neutral gaseous atom to form anion. See here, you can take what neutral chlorine gaseous atom. To this you add electron. So during the process of adding of electron to the neutral chlorine gaseous atom, it changes to anion and there is a liberation of some amount of energy. That energy we consider as electron affinity. For example, you can take oxygen is a neutral atom. To this you add one electron. Okay. Here oxygen changes to O minus and releases energy. This energy we consider as electron affinity 1, EA1. Okay. And you can add one more electron to this O minus and it becomes O minus 2, releases energy E2. This is considered electron affinity 2. So from this you can understand very easily definition of electron affinity. See, what is electron affinity means? The amount of energy released during the process of adding of electrons. Electrons to the neutral atoms, to the neutral gaseous atoms. So that what happens? Atom changes to its concerned anion, and there is a liberation of energy. That the energy we consider as electron affinity. Is it clear now? So amount of energy which is released when electron is added to atom. Okay. When electron is added to gaseous atom or neutral atom, so that atom is changed to concerned anion, and in this process what happens? There is a liberation of energy. That energy we consider as what? Electron affinity. Okay. Right. Completed already. Right. Okay. Completed. Then, after studying the definition of electron affinity, we will study the change of electron affinity in group and period. How it changes. Okay. You write down here only. So in group, what happens? See, electron affinity EA electron affinity decreases in group from top to bottom, from top to bottom, from top to bottom, because size, atomic size increases, because atomic size increases, because atomic size increases, and also and also and also EA and also EA increases in period from left to right, from left to right. So once you know effect of group, and very easy to understand effect in period, because effect in group and period both are reverse with each other. I told you, no. So here what happens? Electron affinity decreases in group. What happens in period? Increases. Clear? Okay. See, this is group. This is group. When we move this side, this is period. Electron affinity. What happens here? Increases. Left to right increases. Left to right increases. Here top to bottom. This is top. This is bottom. Here electron affinity. What happens? Decreases. Decreases. Why? Because size increases. Here reason is electron affinity and atomic size both are inversely proportional with each other. Clear, lucky? Here I give you final relation: ionization energy and electron affinity both are directly proportional with each other, and both these two are inversely proportional to atomic size. This is the final relation. Okay. I give you one question. Among boron, carbon, nitrogen, which one atom is having more ionization energy and electron affinity? This is the question you write here. So question will be like this. In examination, question will come like this. Okay. Among boron, carbon, nitrogen, formulas. Boron means B, carbon means C, nitrogen means N. Nitrogen means N. Among boron, carbon, nitrogen, which one is having more ionization energy and electron affinity? Okay. Here answer is nitrogen. Answer is nitrogen. Nitrogen can have more values, more values than boron and carbon. See, this is boron, carbon, nitrogen belongs to second period. Here what happens? You try to understand. Boron 5 atomic number, carbon 6, nitrogen 7. So when we move from left to right, what happens? Atomic size decreases. AS decreases. Whenever the AS increases, what are increases? Which one is increases? Ionization energy and electron energy. Both are increases. Both are increases. That means here nitrogen is more ionization energy, more electron energy than this two one. Okay. So final answer is what is the order of ionization energy and electron affinity. So nitrogen is more than that of carbon than that of boron. Clear? So among these three, this one is having more ionization energy, more electron affinity. Why? Because size is less. Because size is less. Okay. Here nitrogen can have more values because size is less. Main reason is size is less. Okay. The low sized atom can have more IE and EA. So here reason less sized atom, less sized atom is having more IE and EA. Write down that one. Right. Less sized atom is having more ionization energy and electron energy. This point you should copy. You have to copy. So among these three, which one is less in size? Nitrogen is less in size. That's why more in electron affinity, more in ionization energy. Okay. I give you one homework. See. Among the following question. Among the following. Which atom is more ionization energy and electron energy? That is the question. Right there. Okay. So I give you lithium, then sodium, potassium. Okay, then second one, beryllium, magnesium, calcium. So in this way, which one is having more ionization energy and electron energy? Is lithium. Answer is lithium. Here answer is beryllium. Why? Because among them low size atom. Which one is low size? Lithium is small size. Beryllium is small size. Okay, that is the reason. Small size or less size. Small size atoms having more ionization energy. So here lithium can have more IE and EA. Okay. Beryllium. Here also beryllium can have more IE and electron affinity due to small size. This is the reason you have to write. Okay. This is the way to answer this question. Here. So far we are discussing. So far I am explaining how many properties, periodic properties. We discussed atomic size. Okay, and also we have completed. We have studied second one, ionization energy. First one is atomic size. Second one is ionization energy. Okay, third one is electron affinity. Okay, these three periodic properties we have discussed up to. The remaining part we will discuss in next class. Okay. I want to stop here. The remaining part will continue in the next class.